Unit 3, Problem 36. Use a graphing calculator to graph the function. Explain how to determine an appropriate viewing window. Make a sketch of the graph, including axis labels. Well, okay. First, we want to determine an appropriate viewing window. We recall that the height of the object began at 1,200 feet, and we're just going to guess that our time should be between 8 and 9, 10 seconds. Wait, we don't have to guess. We already worked that out. So, first, an appropriate viewing window would be, let's turn on the calculator. We quit this. The window would be, do we need a negative x? No, because time is never negative. Our smallest x can be 0. Our x max can be 10, that's fine. Our y minimum can also be 0 because the object is only going to fall to the ground. It's not going to go further. It starts at 1,200 feet, so I'm going to set my y max at 1,250 feet, and I'm going to say that 1 square should be 25 feet. I think that would give us a good curve. Now I go to y equals, and our equation is 1,200 minus 16 times our input squared. What will that graph look like? It will look just like that, where time is our independent variable, 1, 2, 3, 4, 5, 6, 7, 8. Bigger than 8, but smaller than 9. Independent variable, time. Dependent variable, our output, height. Have we answered all the questions? Make a sketch of the graph, including axis labels. Well, this is what our sketch would look like. To plot points, we can go to second table and use 1 second, 2 seconds, 3 seconds, 4 seconds. We've already done this in 34. So we can take that same data. We can take that same data and use that to plot our curve. And that answers 36. What is the y-intercept? Explain what it means in the context of the problem. The y-intercept is 0, 1,200. What's the output when the input is 0? It represents time equals 0. The instant before the object is dropped. These are the initial conditions. Explain how to use the graph to estimate how many seconds it takes for the object to reach the ground. Well, we did that pretty well right here. We drop it, it begins to fall. 1, 2, 3, 4, 5, 6, 7, 8. A little more than 8 seconds, but fewer than 9. How can we use the equation to check our answer? Oh, well, to check our answer, if the equation is the output is equal to 1,200 minus 16 times the time squared, where the height is 0, that's going to equal 1,200 minus 16t squared. Subtract 1,200 from each side. Multiply both sides by -1. Divide both sides by 16. 1,200 divided by 16. 75. The square root of 75 is 8.66 seconds. There we go. 8.66 seconds.